So let f be a function with the following property. This is the graph of the function. So this is y is equal to f of x. So I'm not being given a formula, I'm just being given the graph. Now, is it increasing or decreasing? I can definitely see it doesn't feel like it's decreasing anywhere, right? Because of the fact it just seems to be going up as I move from left to right. What about increasing? So this is a bit more delicate. It is not overall increasing. And as an example, if I was to take this position here and this position here, so that's up there and that's down there. That's no good, right? That's what decreasing does, not increasing. If that happens at any point in my graph, then I can't be an increasing function, not overall. But I am an increasing function as long as I restrict to certain intervals. So this most definitely is increasing on two kind of intervals separately. Increasing on, so minus infinity to 1, not inclusive of 1. If you included 1, then you'd have the problem of this occurring, right? Which is no good, it would be dropping down. So you can't include that. So it's increasing on this, and it's also increasing, so I'll do this totally separately. It's not increasing on the union or anything like that, it's increasing totally separately, increasing on the interval 1 to infinity. And if you want now, you could have this as a closed interval, because 1 is at the bottom, it's totally fine. But again, it's not increasing on the entire thing, precisely because of what I've described. If I was to choose, again, that point there and that point there, it would go down as I move from left to right, which is not what I want from increasing. So these properties are local in the sense they are on a restriction of the domain. The domain of this function is all real numbers, right? Any input's totally fine. So these are local. The increasing is only once I restrict to intervals, basically. So this is not a global property. It is not globally increasing. It's quite subtle.